We've been looking at graphing trigonometric functions, finding equation of trigonometric functions given information. And so here's a word problem, and we're going to try to figure out what the trigonometric function is that relates this information to the word problem. So we all, well, maybe not all, but I do. I love roller coasters, and this problem deals with roller coasters. So a wooden roller coaster contains a run in the shape of a sinusoidal curve with a series of hills. The crest of the hill is 112 feet above the ground, and it takes a car 1.7 seconds to go from the top of the hill to the bottom, which is 4 feet off the ground. Find the sinusoidal function of the form y equals a sine of, I believe that's omega t minus v plus b. That models the motion of the coaster train during the run, starting at the top of the hill. Okay. So we have some roller coaster. It tells me right here that that roller coaster is 4 feet off the ground. And that's from the bottom of the hill. And so if that's 4 feet off the ground, that tells me that's going to be the minimum value. Let's not have this to scale. This is not to scale. And then we know that the maximum value is 112. And it takes the car 1.7 seconds from the bottom, from the top to the bottom. So we're going to try to find this curve. Okay, so sometime here, we're at the top. I know it's going to take 1.7 seconds. Actually, let's do this. Let's just start here when time is 0. So we know at 1.7 seconds that we're going to hit the minimum. And it said it forms a sinusoidal curve. So I'm just going to assume that if it goes from 0 to 1.7, so a halfway mark between 0 and 1.7, that would give us our midway line. So 1.7 divided by 2, that gives us 0.85. So that's halfway up. And then, so that tells me that 0.85, if I added that to 1.7, that would give me my 3/4 mark. So my 3/4 mark is going to be at 2.55 seconds. So we'll hit back up to the midway line and then adding another 0.85 there. That means at 3.4 seconds, I'd hit back up to the top. So if it hadn't told me which function to use, I probably would use cosine, but it told me I want to use sine. So we want to figure out what our amplitude is. We can figure out our amplitude. This is equal to the max minus the min value and divide that by 2. So our maximum value in our case is 112 minus 4 all over 2. So 108 divided by 2 gives us back 54. So our amplitude is 54. And that's the absolute value of A is 54. We'll talk about, is that positive or negative, depending on where we're starting. We need to figure out how much we're shifting this up. And so we can figure out what that midway line is, that shift, which in this case, they gave us, this was capital B. This is equal to the max, 112, plus the min, which is 4, and then divide this by 2. So B is equal to 116 divided by 2, which is 58. So looking at a period, so from looking at where it starts one place, let's just start at 0, and does one full cycle, it will start again at 3.4. So I can see my period is equal to 3.4. So I'm going to need to figure out what B is, or in our case, omega. So I know my omega is equal to, well, my period, which is 3.4, is equal to 2 pi divided by omega. So multiply both sides by omega, we get 3.5 omega equals 2 pi. Divide by 3.4, we would get omega is 2.5 or 2 pi over 3.4. I'm just going to leave things unless it tells me not to. In exact form. And then the phase shift. So because I'm thinking of a sine function, I want to think about starting at the midway line. And so my phase shift here is 0.85. So I know what my phase shift is, which is 0.85. This is equal to my phi divided by omega, but omega in our case was 2 pi all over 3.4. So if we multiply both sides of our equation by this 2 pi over 3.4, so we get, let's see, 0.85 divided by 3.4, which is 0.25 times 2. That's giving me 0.5 pi is equal to phi. So if I plug all this stuff back into my equation here, we have y is equal to a. This is where we had to decide if it's positive or negative. But from the midway line, we're decreasing. So I know that has to be a negative value. So minus 54 sine omega, which was this 2 pi over 3.4. They wanted t for time, minus phi. Phi was positive, so minus 0.5 pi. And then plus our shift, and we shifted up 58 units, so plus 58. So this should be the equation for that roller coaster.